Good morning, class. This presentation video is about the final project I did for the NoSQL databases class. The application that I'm going to create the database for is to manage the smart devices that we all use in our houses today. They are primarily domestic devices like the internet connected thermostat, internet connected kitchen where you have stove, microwaves, and ovens connected to the internet, and you have electrical items like bulbs connected to the internet. You have security systems connected to the internet. You have things like baby monitoring systems connected to the internet. Even you have like plumbing items like pipes are connected to the internet. So we are living in this world where a lot of devices are connected to the internet, and this picture nicely shows how home has a lot of many different smart devices and how they are connected to an user. So I thought about an application where we'll be storing data from these different applications and provide a seamless experience to the user in terms of, okay, your thermostat has reached this much, or if you leave the house, the thermostat gets turned off automatically, or one device communicates with the other device and makes something happen, things like that. So that is the idea behind this project. So if we scroll down, so I created some sample data. You can see it here, where I took 3 users, and the users have names and address and city, zip code, state, phone number, internet provider, what the status of phone and internet are. And I also created some sample data for the device itself. So you can see here user John Newton, which with the user ID J Newton, owns a thermostat, a stove, a light. All of them are smart, connected to the internet. And I also gave some status, manufacturer, version, what mode it's on right now, what function it's doing right now, current value, set to value, maybe some threshold value, what date and what time this data was captured. So the idea is that the device will be sending out data on a time based manner. Maybe an hour, every hour we get data from the thermostat, or every 2 hours we get data from the stove. That'll get recorded in the database. Okay, that's the high level idea of the application. And the application need not store the historic data that comes from the devices, which could mean a lot of data. So we'll probably store the data from the last 24 hours, or the data from the last record, and move the rest to a historical a data structure which can be queried for patterns later. All right. So with that in mind, I've jumped into the data model. Um, from a logical model perspective, there are only two entities here: a user entity and a device entity. The user, I'm assuming that user ID is unique for a user, a device ID is unique for a device, and a user can have many devices. That's the high level logical model. And I also took a stab at how the data structure can look like. And based on the sample data I have, John Newton owns a stove, a thermostat, and lights. Tom Edison owns a sound system, thermostat, and a sprinkler system. Mary Curie, a third user, owns a security system, monitoring system, a stove, and a thermostat. So that gives some of the instances of the data we're going to model. So then I looked at the databases we studied in our class in order to look at the pros and cons of each and decide which one to use. So I looked at Cassandra first. Cassandra as a columnar database is highly scalable, provides high performance, and it's a great database for IoT type applications. It stores data by column families, and each row on a column family can be different. Columns can be added, altered on the fly. That provides extremely high flexibility for the application designer. There are no joins in Cassandra, so that needs to be managed from the application side. That means no relationships there. Cassandra can have a huge number of columns in millions, and it's great for fraud detection applications and gaming industry application. The next one I looked at is the document databases, and one of the document databases we study is MongoDB. Document databases store data in documents, and also you can insert sub documents inside a document, and The properties on the documents and the subdocuments can be different. That provides extreme flexibility to the application designer. The data is also it's very highly available, scalable, and provides high performance as well. And the subdocuments, as I said, and the relationships in terms of references between documents provides the joining capability in MongoDB. It's great for content management, storing log data, and also IoT management type data management. Graph databases are great when you have a lot of relationships. The database we study in the class is Neo4j, and entities are modeled as nodes, and relationships are defined between nodes. They're directional. Nodes and relationships can have their own properties. So graph databases are very useful when you have a lot of users connected to each other, like in social media, or the things, the products the users like that you want to show on an e-commerce site. So it's a great database for that. And key value databases are really simple. That's what makes them really useful. And they are keys, literally keys and values. They're great for managing shopping carts. They are limited in memory. They only use a RAM, so we cannot be having a lot of data there. But they're great for, say, e-commerce shopping cart applications. So based on the databases we looked at, I ended up picking MongoDB for this application, mainly for two reasons. Its flexibility and simplicity in terms of subdocuments and references, and it provides real-time analytics. And so then I started working on the data model. Then I ended up with three options for the data model. I can store the device data as subdocuments under every single user document, or I can create a device parent document and store the user as a subdocument, and or you can store the user and devices at separate collection and have a reference of the user in the device. I ended up picking option one because we were only going to have a handful of devices per user. So and we always almost query the user every time we look up a device. So you look what's going on in a device, and then you go to the user to notify the user, or create an alert. So we decided to go with option one, where the data structure can look like this. We'll create a user collection with the user attributes, and there'll be a device collection where we can have device A, device B, and it can go on. And each device can have different set of attributes, which works perfectly for this application. I also created a thought about a user history collection. It looked the same. Maybe we can add a indicator to say it's history, but that's going to store all the historical application data, which is not needed for the real-time alerts. So here are my insert statements. So I started inserting, he's the first user, John Newton, and he's got a thermostat, and he's got a stove, then he's got a light. And then I jump to the second user, Edison, same thing, different devices for him. Mary Curie, same thing, 4 devices for her. And then I started make sure that the data is inserted. It is. And then I started doing different updates on the data. Okay, how many total users we have in the application? Who owns a thermostat, and who wants a Nest thermostat with version lesser than 1.4? They need an upgrade, right? We can send an email out to them, and find the users who own devices that are inactive. Who own users who own devices that are related to entertainment. They can have a different type of experience. And it goes on, right? Return all devices owned by Mary Curie if you want to do some work there. Then I added a smart TV application to John Newton user, and a few more update statements. And then I removed some records. I made some records to reach the threshold value to send an alert. I was able to perform all the things that I were intending to do. So for this project, MongoDB turned out to be a great database. So I learned that how flexible it is in terms of documents and subdocuments, and how easy it is to query the system in order to send out alerts. So that brings me to the end of this presentation. Thanks a lot for watching this.